All right, here we go. Unit 4 test review, page 4, the last page. So we got some more proofs, obviously. So let's do it. Wait a minute. I'm pretty sure this was a homework problem. ADDG. Yeah, this is a homework problem. All right. This was on homework 4.6. I think this is the first homework problem on section 4.6. So let's do it anyways. All right. We know AD is congruent to DG. I think these are different letters. We know DC is congruent to DE. All right, very straightforward. So what we should do is, with all of that given information, we should kind of establish which triangles do we want to focus in on. All right, so let me just get this all drawn out here. We have AD, so step 1. AD is going to go ahead and be congruent to DG, and we have DC. DC is going to be congruent to DE. All right, that's going to be step 1. Now, step 2. Before we kind of jump into step 2, let's decide what triangle would make the most sense to start with. Now, we have these green, it's supposed to be green. We have these green triangles, right? These skinny green triangles, right? Then we have these blue, I guess, kind of medium-sized triangles, all right? And then we're going to have these orange triangles that are just kind of the whole thing, all right? So those are the biggest ones. So if we look at the green triangle, all right, we know that we have AD is congruent to DG. Okay, so that's true. If we look at the blue triangle, all right, if we look at the blue triangle, I'm in the way. We look at the blue triangle, we are going to have CD is congruent to DE. All right, so now that's only one thing from each triangle. Now notice how we can say all of these do have vertical angles, all right, and we are going to use that fact later on. All right, so now if we look at the green triangle and the blue triangle, they only have 2 pieces of information. They have one side each, and they have one angle each. But if we look at the orange triangle, all right, the big old orange triangle, we got A, C, D, E, and G. All right, we were given AD is congruent to DG, and CD was congruent to DE. Now, just like on the green and the blue one, we also have these vertical angles. All right, so if we just look at all 3 of those triangles, it would make the most sense to pick the orange one. All right, so I'm not even going to bother with the green one or the blue one yet. All right, we'll come back to those. So I'm just going to put these back where they were, and we are going to focus on proving the orange one. All right, so we'll come back to that. Let me get rid of all this stuff. All right. Now, from here, we said we we're going to focus on the orange one. Now, the only thing we need to mention about the orange one is that we have those vertical angles. So those big vertical angles are angle ADC. So angle ADC is going to be congruent to angle GDE. All right, how do we know that? We know those are vertical angles. I'm going to abbreviate. Those are vertical angles. So if you guys are watching this on mute, you're going to have a bad time. All right. So we were given, we had our vertical angles. Now, those orange triangles, we have enough information now to say that those are congruent. The orange triangles are an SAS triangle. So let's see here. I'm going to say C, I guess the order of the first one doesn't matter too much. I'm going to say ADC. Angle ADC triangle ADC, remember step 2 and 3 are different. Triangle ADC is going to be congruent to GDE. All right, and how do we know that this is side angle side SAS? Okay. Now from here, this is the part where you guys are going to go, different. So you might do something, your neighbor might do something else, but you both could potentially be correct. Now we have to pick one of the other two pairs. We could pick the blue one, or we could pick the green one. All right. So let's just I'm going to look at these overlaps one more time with green, with the orange, and I like the color blue more than green. So we're going to look at these two. Right. So they do have some overlap. Now, what we need to do is on this orange triangle, we need to say something about like a CP-CTC, right? Because we just used a triangle congruence theorem. So we already know step 4 without even thinking CP-CTC. All right, step 4. We need to mention something is congruent. Now, look at those triangles. The only thing that they have in common is side CD and side DE. All right, that's the only side they have in common. We cannot say that top and bottom piece are congruent because it's just a part of the whole thing. All right, we know that top orange piece is congruent to the bottom orange piece because of CP-CTC, but we do not know the blue top and the blue bottom are congruent. Right, so that top orange one could be like 10 units long, so the bottom orange one is 10 units long. But the blue one, it could be like a 4 and a 3. So we don't know that they are the same yet, at least. So the only other thing that these two pictures have in common is that angle. They both have angle C and they both have angle E. All right, so we know by CP-CTC that angle C is congruent to angle E. All right, so we know that is true. So now let's go. I'm going to get rid of this orange triangle. We're done with the orange one, so I'm going to put that back. So now let's focus back on this blue one. We have an angle and we have a side. All right, so that's two things. We need a third one, but some obvious information. We've talked about getting these obvious things. It's not explicitly written, but we know this property to be true is a vertical angle. All right, so we know angle. Let me put these letters back in. This should have been a B, and this is an F. All right, so we know that we have those vertical angles. You cannot say angle D is congruent to angle D. That doesn't make any sense. So on the blue triangle, we know that angle BDC is going to be congruent to angle FDE. All right. How do we know that? That's, again, those are vertical angles. All right, so now let's look at those blue triangles. The blue triangles are congruent. How do we know that? Let's see, here we got triangle. Let me just write these down. Triangle BDC is going to be congruent to triangle B to D to C. That's going to have to go FDE. All right. Those are congruent by the angle side angle theorem. Okay. Now, the last thing we wanted to show, right, our proof statement here, we wanted to show that BD is congruent to DF, and we're there, right? We can say step 7, BD is congruent to DF. How do we know that? We know that from the corresponding parts of congruent triangles are congruent theorem, right? CP-CTC says that those are congruent. All right, and that one's done. So now I got two more proofs for you here. These are the we call them proofs by proofs by contradiction. We call them indirect proofs. There's a couple different names for them, but notice how we have these little slashes through some of our symbols, right? This first given, AB is not congruent to AD. And then the proof statement, prove AC is not perpendicular to BD. All right. So remember, we kind of have a process of doing this. The first thing we should do is we should pick all but one of our givens. All right. So what we're going to do is we kind of have two given statements here. So we have AB is not congruent to AD, and then we have AC bisects angle BAD. Then what we're going to do is we are going to assume the opposite. Assume the opposite temporarily. We're going to temporarily assume the opposite, and we're going to show that that leads to a contradiction, two things that say the exact opposite. Now, I'm going to type this all out. So let's see what we can do here. All right. First things first, take all except for one of your givens. So the one that you shouldn't use is the one with a little slash through it. So we are going to use given 2 in this one. So first things first, temporarily assume that AC is perpendicular. All right, we're going to temporarily assume that AC is perpendicular to BD. And we're also going to assume the other one. So also assume that AC bisects angle BAD. All right. So just from this assumption, here's kind of what we have. So if we draw on our picture, all right, we have a perpendicular angle, all right, and we have AC bisects BAD. So we know that these top angles are congruent. And I know it doesn't look like they're the same, but remember, this is just, we have to go off of our given information and our temporary assumption. All right, so let's see here. So since let's see, BC is perpendicular to AC, we know that angle BCA, we know that angle BCA equals 90 degrees, and ACD, angle ACD equals 90 degrees. Therefore, angle ACD, ACD is congruent. I'm going to say equal. I don't know how to make a congruent symbol. Therefore, angle ACD is congruent to ACB. All right. So that's kind of one thing we have. So we also need to mention the angles up top. So since AC bisects angle BAD, we know that BAC is equal to or is congruent to CAD, because that is the definition of bisect. All right. So these proofs by contradiction, we kind of write them as paragraphs. We don't do a 2-column chart. All right. So here's another thing. Notice that AC equals AC by the reflexive property. Right. So if we just write that in there, we have the reflexive side now. So I'm going to draw that in here. Right. So since we have that reflexive property, therefore we know that triangle BAC is congruent to, I'm going to put equals again, triangle BAC is congruent to triangle DAC. By the, what theorem are we using? We are using the angle side angle theorem. All right. So since the triangles are congruent, we know that AB is congruent to AD by the CP-CTC theorem. All right. And there we go. This is the contradiction. All right. So we just said AB is equal to AD. But if you look at our given information, the given information says that those are not congruent. All right, so this is a contradiction. Those are two things that are saying the exact opposite. All right, this contradicts our given information that says AB is not congruent to AD. Therefore, our temporary assumption must be false. And we must have that AC is not perpendicular to BD. All right, so remember, the whole reason we were able to say that these triangles were congruent is because we temporarily assumed that they were perpendicular. All right, so when we assumed they were perpendicular and it led to a contradiction, the opposite of our temporary assumption has to be the true one. All right, so we temporarily assumed AC is perpendicular to BD. We said that was false, so the only outcome is that AC cannot be perpendicular to BD. And this is how we prove something by a contradiction. All right, and there we have it. Let's try one more. All right, we are given D is the midpoint of CB. All right, so let's look here. We have two pieces of given information. All right, and we want to use all but one of them up until the very end. And then we want to do the opposite of the proof statement. All right. So here we go, round two. Temporarily assume. How do I spell it? T-E. Here we go. Temporarily assume that D is the midpoint of AE. Also assume, so we're going to assume that first statement, also assume that D is the midpoint of CB. All right, so the only one we don't want to use is the one that has the slash through it in our given statement. So we do not want to say that the triangles are congruent. All right, that's the one we're going to use to bring out our contradiction. All right, so next, what do we have here? So we have two midpoints, okay? Since D is the midpoint of both CB and AE, we know that AD must be congruent to, right? Since D is right in the middle of AE, we know AD must be equal to DE. We know that AD is congruent to DE and CD is equal to DB, right? Since it's the midpoint of both of those segments. We know this because it is the definition of a midpoint, right? A midpoint makes two congruent segments. So let's go ahead and mark that on the picture. All right, now the next thing we can mention are these vertical angles. All right, so we know that those have to be congruent. So let's go ahead and mention that. All right. All right. Notice that you say notice or observe, or we have vertical angles. You can even just say angle ADC. Angle ADC must be equal. Let's see, ADC must be equal to angle EDB. Because they are vertical angles. All right, so looking at this, what can we say now? By the SAS theorem, we know that triangle ACD must be congruent to triangle EBD. All right, so there it is. That's bad. All right, so let's look at this. This statement right here, triangle ADC must be congruent to triangle EBD. That is the exact opposite of our second given statement. We were given, so let's say that triangle ACD is not congruent to EBD, which is a direct contradiction to what we have shown. Therefore, right, so we show that they were congruent, we were given they're not congruent. All right, so the only thing that must be true is that our temporary assumption is false, right? The whole reason we were able to get that these triangles were congruent is because we assumed the opposite of what we were trying to prove. We assumed that D was the midpoint of AE. So this assumption right here, there's no way that that has to be true. So the only other option is that that has to be false. Therefore, our temporary assumption that D is the midpoint of AE must be false. So we must have that D is not the midpoint of AE. All right. And there we have it. Right. So you need to bring out a contradiction. You need to point out the contradiction on these, and then you need to say, since our temporary assumption gave us a contradiction, the opposite of what we assumed must be true. All right. So there we have it. These contradiction proofs, it's almost like a totally roundabout, backwards way of trying to prove stuff, but it does work. And there we have it, right? So that is our Unit 4 test review. That is, everything. I hope these videos were good enough for you guys. If not, let me know if you have any questions, and we can go from there.